Alrighty. Today I think should be pretty quick and easy. Just try to decide whether things are linear in nature or whether they're not linear or non-linear. Very simply, a linear equation is always y equal to mx plus b. And the most important part that you need to understand is that the number in the y spot has a power of 1 above it, and the number in the x spot has a power of 1 above it. Okay? Typically, your m, which is your slope, and your b will be numbers. But as long as your y is being raised to the first power, or the letter in the y spot is being raised to the first power, and x is being raised to the first power, or the letter in the x spot is being raised to the first power, if they're both power 1, you have a linear function. So in example 1, I got a and I got b here. One of these things is linear, the other one is not. Well, in both cases, y has a power of 1 above it, even though I don't see it. But both x and y need to be power 1. That's power 1. That's not power 1. So this is linear, and this is non-linear. Now, I'm not telling you what it actually is. You have to just know that it's not a linear function because it does not have power 1 above the x. Example 2 is when we have a graph. Now, could be super easy. If you look at the graph with the blue dots and the graph with the red dots, which one goes in a straight line? Well, the straight line is this guy. All the dots in a straight line, so therefore it's linear. This one, you can't put a straight line through all the dots. It's all messed up. It goes in different directions. This is non-linear. And this is linear. Okay, last thing here. What if I have a table of values? I need both x and y columns to go up by equal amounts each time. If they each go up by equal amounts from one x to the next, from one x to the next, and the y's do the same thing also, they are linear in nature. So here I'm going plus 1, from 2 to 3 is plus 1, from 3 to 4 is plus 1, from 4 to 5 is plus 1. They're all going up by 1, which is a good start. But the y's have to go up by the same amount also. Now, not necessarily do they have to always go up by 1 like the x's did, as long as they go up by the same amount from one of the y's to the next y. So from 3 to 8, we go up 5. From 8 to 13, up 5. 13 to 18, up 5. And 18 to 23 is up 5. Did the x's all go up by the same amounts? Yes, by 1 each time. Did the y's also go up by the same amount each time? Yes, they each kept going up by 5. This is linear. If I look at the x's in the other example, again, from 1 to 2, and 2 to 3, and 3 to 4, they all go up by 1, which means the x's are consistent in their nature. They keep going up by the same amount each time. They're consistent. The y's, from 1 to 4, goes up by 3. From 4 to 9, we go up by not 3. From 9 to 16, we go up by not 3 again, which is changing all the time. Even though I have consistency amongst my x values, I do not have that matching consistency in my y values. This is a non-linear function.